I'm in the Rolls-Royce Aero engine factory in Derby, and this is their latest engine, which they're billing as the world's most efficient. Now, Chris Young, you've been pulling all this together. What makes this engine so special in your view?
So this is the largest engine that we've ever done, and as you said, the world's most efficient engine. It's the biggest diameter of fan that we've ever had. This is 118 inches of diameter. You could fit the Concorde fuselage through the centre of this casing here. We take air in, it's about 1.3 tonnes of air a second, about the same as emptying a squash court every second through these blades.
And that flows through here?
And that flows through these blades. These are hollow titanium blades.
Can I touch them?
Yeah, you can touch them.
They feel almost too thin to be hollow.
Yes, they're amazingly light technology, very, very thin, hollow inside them to make them very, very stiff. The blades run with an immensely close clearance onto the casings. Once it's running, it's far less than 1 millimetre of clearance.
So the air then flows inside here. Now there's this mass of wires and cables and so forth. What happens next?
Some of the air flows through a duct that would be here, the bypass of the engine.
And that drives the plane forward?
And that drives the plane forward. Some of the air, just over 10% of the air, flows through the core of the engine, where we compress all of the air through the compressors that sit through here to 50 times the pressure. A combustion system here runs around about half the temperature of the surface of the sun. Then expand the air through the turbines here. The air at this point, it's hotter than the melting point of the turbine blades themselves.
Sounds almost impossible.
Sounds impossible, but the way we achieve that is by putting a very thin film of cooling air around the blades themselves.
And that just flows over them.
And that just flows over the blades. Though even the cooling air itself is at nearly 800 degrees. This is where the air comes out of the core of the engine. You can see the last stage here of the low pressure turbine blades. All of the air that's come through here has been expanded through those turbine blades. They try and extract as much power out of the air as possible, and then there's a shaft that runs through the middle of the engine back to the fan at the front of the engine, and it's all the power that comes out of these turbine blades that turns that fan and allows that 1.3 tonnes of air a second to be compressed and accelerated by the fan, which provides the thrust. Each one of these at takeoff power is capable of 84,000 pounds of thrust.
Now, I know that we're the first TV crew allowed in here to see this engine, but I'm sure there's all kinds of secrets you've got locked away, because it's a highly competitive business, isn't it?
We're all improving by about 1% a year. There's huge amounts of technology investment that goes into creating the secrets on here, not just in the individual technologies, but how to manufacture things and how to integrate them all, how to model the engine to make the engine as perfect as it can possibly be. So yes, there's a lot of secrets buried away in here that we wouldn't like anyone to get their hands on.